Hello everyone, let's do year 2006, the main paper. Now, question 1. This is a giveaway question. They actually gave you a table asking you to complete it. You're given the element, proton number, and electronic structure. Now, in the periodic table, just remember that the top number is called the mass or nucleon number, and the one at the bottom is actually the proton, or also called the atomic number. So written for you here, what you will see on the periodic table. So straight away, question on proton number. That for lithium, that will be 3, aluminum 13, potassium 19. Now, please take note, electronic structure, the newer way of writing is this. Okay, if you want to write it in comma, you need to put your bracket, but I would prefer this. First shell takes up to 2, so left with 1 for lithium. For aluminum, 2, 8, that's 10 plus 3, 13. And for potassium, 2, 8, 10, plus another 8, 18 plus 1, that's 19. Okay. Moving on to question 2. You're given boxes, which are diagrams trying to show different atoms, how they are arranged, so on and so forth. They ask A, B, C, D, which is a gas made up of single atom, monoatoms. So we're looking at things with one single circle. So that must be B. Hydrogen gas, we know that hydrogen gas exists as a H2 molecule, 2 hydrogen atoms joined together. So the answer must be C. Mixture of gas, you have A. And then the solid, this is the solid, liquid, and gas kinetic particle theory that we usually draw. This is for solid. Alright, let's take a look at question 3. Question 3, 2 white powders accidentally mixed. They told you that one is silver nitrate, soluble in water. The other is silver chloride, which is insoluble. Now I've given here solubility of salts, if you need to recap, that all spar salts are soluble. Any sodium salt, potassium, ammonium, all the nitrates are soluble. All chlorides are soluble except for your LS, lead and silver chloride. All sulfates are soluble except for your LBC or CBl, lead, barium, calcium sulfate. Okay, all carbonates are usually insoluble except for your spar. Okay, which is the same as the first rule over here. Now, having said that, thankfully they gave you the question. Both chemicals are expensive, and what do they want you to do? They want you to separate the mixture, and they want dry samples of each one. Okay, let's see what they gave in the answer. So over here, of course, firstly you add water. You know that silver nitrate is the one that dissolves in water. Then you have one that's soluble, one that's not. Stir, filter, then you can just get the silver nitrate as residue. So keyword here, you must have the word residue. If you want, you can even say that silver chloride is the residue, silver nitrate is the filtrate. That will be even more specific. Okay, then moving on, how do you get the salt back from the solution? So you have to heat. Actually, this whole process here is actually crystallization. Okay, so let's take a look at what are the keywords that you must have. Now, heat. Firstly, you must heat. Heat until when? Saturated. Okay, this is usually about 1/3 of the original volume. Then when you cool, let the crystals form, and then keywords include filter, okay, and dry by pressing between pieces of filter paper. Usually we include wash also with distilled water. Filter, wash, dry. So keywords: heat, saturated, cool, crystals, filter, wash, dry. These are the keywords that you have when you're describing crystallization. Okay, question 4, not very clear on this, but it's okay. It's trying to investigate the rusting of iron. 5 nails, each weighing the same mass. Different treatment, left in the air for 10 weeks, and then they weigh it again. So you have a before and after. Okay, before is all 5, then after there's some change. Part A, asking you to plot the graph. So let's see. Okay, so this is quite interesting though. You need to take note of what they actually gave you. So it's kind of like a bar chart that is given. So take note of your values. Just follow very carefully. Okay, y-axis is mass against the different kinds of conditions. Let's do 4 part B. For part B, we are looking at conditions needed for rusting. Definitely you need water and oxygen. What can speed this up? That's not really a condition, but if we can actually speed it up in the presence of salt or heat. Okay, next part C, may not have mentioned this before, but take note that the word galvanize, I'll write it clearly for you. Galvanize means that it's coated or strengthened with zinc. Last but not least, they're asking why bicycle frames made from stainless steel. We know that this is an alloy, okay? But the handlebars aluminum. Okay, they ask why aluminum is preferred. Okay, maybe characteristic of aluminum. It has a lower density, so it's more lightweight, so to speak. Okay. Okay, let's do section B. Section B, question 5. Now you're given a metal, copper. Okay, I'm going to use red here because copper metal is usually reddish brown, as in the copper wires. They say that copper can be produced by heating copper oxide in a stream of hydrogen. Okay, so they pass the hydrogen through this, then the copper oxide, they try to get the copper back from copper oxide. Okay, this one may not have learned this before, but this is a reduction reaction whereby the oxygen is removed. Continue. Part 2. Part 2, they ask you to calculate the mass. So I've enlarged the equation here for you. Okay, so let's take a look. Question says, okay, 8 grams of copper oxide. So you have 8 grams of this. You're given the mass. Okay? First part asks for equation. And then what did they want? They want us to find the mass of the copper form over here. Now, from the equation, we know that this is a 1:1 mole ratio, meaning 1 mole of this reacts with 1 mole of this to produce 1 mole of this and 1 mole of water. Okay, so what do? Find moles first. How do we find moles? Yes, your mole Mr. formula. Okay, so you're taking mass divided by mR. So find your moles. So this is what this one is trying to say. mR of this copper oxide, add them up together, I think it's 64 plus 16 if I'm not wrong. So you get 80. Copper is just 64. So if in terms of mole, okay, in terms of number of moles, that would be 8 divided by 80, correct? Which is 0.1. Since from the equation, copper oxide 0.1, this one will also be 0.1. Then you can times back the mR. So mole 0.1, you times back the mR of 64 of the copper, you get 6.4 over here. Okay, 5 part B. This is a question whether you know the difference between alloy and a normal metal. So mixture of metals and other elements. By the definition, it's an alloy. Why pure copper not used? Because it's too soft and doesn't hold its shape. Next part, they actually ask you to draw an alloy. So remember, there are 3 marking points here. Number 1, I'm looking at different sizes of atoms, and you must fill at least 3/4 of the box. And it will be better if you can show the disorder, that the layers of atoms are no longer in a regular arrangement. Okay? Last part, why is it important to recycle metals? Keyword, they are finite resources, limited. Okay, therefore necessary to conserve them. Question 6, this graph question, farmer uses water from a pond. Okay, I want to find out, it finds the pond water too acidic. He reduces the acidity by adding lime, okay? So most likely calcium oxide. And then they take the pH readings. This is what happens. So they ask you to plot the graph of y against x. In this case, the bags. X-axis, the bags. Y-axis, the pH. pH against the number of bags. So from the graph, after you've plotted this, okay, how many bags is needed? Find out where 7 is, read it off. Okay, that's about 9. Let's take a look at part 3. Now, in order to test the pH of the pond water, what can we do? We can add a few drops of universal indicator. Now, this original color is green. If it's acidic, it will turn from green to red. And if it's alkaline, it will turn to blue or purple, or even violet. Okay, so you dip a piece of pH paper into the water. Next, notice air pollutants are usually acidic gases. So we have nitrogen, oxides of nitrogen, and sulfur dioxide. These are non-metals, because non-metals, when they join with oxygen, non-metal oxides are acidic oxide. Okay, go and recap the different types of oxide, be it basic, acidic, amphoteric, and neutral. Next part is just a filtration technique to remove impurities, and it's a fact that chlorine can be added to kill bacteria. Okay, what are hydrocarbons? Basically compounds containing hydrogen and carbon. The term saturated, you must have the phrase carbon-carbon single bonds in your answer if you're talking about the term saturated. For part B, the table names 6 members. So we know the names MEPB. And we're going to go further. Pentagon, pentane, hexagon, 6. So that's the number of carbon in each of the compounds. They give you the boiling point over here in the last column, asking you to plot the graph. So your x and y-axis, you need to be careful. Your x-axis will be the number of carbon, and your y-axis will be the boiling point. It's always y against x. So after you've plotted the graph, you can use the graph to predict the boiling point of pentane. So fifth one, draw the dotted line, do it across, read from the y-axis. Most likely that will be 35 degrees Celsius. Part C, methane burns to form carbon dioxide and water. So methane, CH4, oxygen, because combustion you need oxygen, produce carbon dioxide and water. Write the big numbers to balance the equation. There's 4H over here, so 2 times 2. Write a big 2 in front. And then because of this, 2 oxygen plus 2 oxygen here, that's 4, so 2 times 2 is 4. That's how you balance the equation. Next part, asking you to name the reagent to test for the presence of carbon dioxide. You either bubble or pass the gas into lime water, which is calcium hydroxide. Oops. There we go. And if carbon dioxide is present, a white precipitate is formed. Last part D asks to draw an alkane with 8 carbons. And just make sure you have the carbons. Okay, this is actually octane. Check that all carbon has 4 hydrogen bonds. And there you go.